Hi, in this video I'm looking at this problem here where we're asked to find the area enclosed by the two functions y equals 4 minus x squared and y equals 5x minus 2. So if we have a quick sketch of these two functions, we'll see what we mean by what we're trying to achieve. So the graph y equals 4 minus x squared will look something like this, where this will be y equals 4. And so if we draw the other one on there, y equals 5x minus 2 will look something like this. And if I extend that down, so what we're trying to do is we're trying to find the area that's enclosed by these two functions. And by that, these two functions both continue on. I've got y equals 5x minus 2 is just going to keep on going on. And y equals 4 minus x squared will also just keep traveling on. But the area enclosed by them is just going to be the area created by this little envelope here. So we want this area here. So to do that, I'm going to let f of x be 4 minus x squared, and I'm going to let g of x be 5x minus 2. And to find this area between the two curves, we first find the difference equation d of x, which is f of x minus g of x. And this equation gives us the difference between the two. So if I work that out, that gives us that f of x is 4 minus x squared, and then I've got a minus of g of x, which is 5x minus 2. And I've got to use the brackets to make sure I get this negative right. Make sure that this makes everything in g of x negative. So this gives us, well, 4 minus x squared, we'll just leave alone for now. And then we're going to bring that negative in, we're going to have minus 5x, and the negative and a negative makes plus 2, and then tidying all of this up gives us d of x is going to be negative x squared take 5x plus 6. And this function has roots at the points where these two cross over. So these two cross there and there, so it's going to have a root there, and it's going to have a root there, and it's got a negative x squared, so it's going to be a sad, so it's going to be a parabola that comes up and then down through those 2 points. And so we can find this area under this curve, under the purple curve, because it's going to be the same as the area between my two curves. So what I need to do is I need to find these two roots. I need to know where these are, so that way I can integrate between here and get the area under this single curve. And that'll be my answer. So let's find the roots of d of x. So 0 is going to equal negative x squared take 5x plus 6. And to do the roots, we can either use the quadratic formula or we can try and factorize. This one actually factorizes, so we can find what multiplies to make negative 1 times 6, so negative 6, and what adds to equal negative 5. So the answer to this is going to be negative 6 and 1, because negative 6 times 1 is negative 6, and negative 6 plus 1 is negative 5. So we're going to have 0 equals negative x squared take 6x plus 1x plus 6. And then factorizing from here, if I take out negative x, so if we factorize out negative x, I'm going to have x plus 6 left. And if I take out 1, so if I take out a 1, so plus 1, I'm going to have x plus 6 left again. So 0 is going to be x plus 6 times negative x plus 1. So that means that my two roots are that x equals negative 6 or x equals positive 1, because negative x plus 1 equals 0 becomes negative x equals negative 1. The negatives cancel out, x equals 1. So they're my two roots. So they're the bounds that I'm going to integrate by, and I'm going to integrate d of x. So now let's do that integration. So the area under the curve is given by the integral of d of x between the roots of d of x with respect to x. So we've got the integral between negative 6 and 1, between negative x squared, take 5x plus 6 with respect to x. So if we do that integration, that gives us negative x squared integrates to negative x cubed on 3. Negative 5x integrates to negative 5x squared on 2. And 6 integrates to plus 6x. And we're between 1 and negative 6. So now working this out, we are going to have, substituting the 1 in, we're going to have negative of 1 cubed on 3 minus 5 times 1 squared on 2 plus 6 times the 1 minus of negative of the negative 6 cubed on 3 minus 5 times the negative 6 squared on 2 plus 6 times negative 6. Working those out gives us that we have negative a third minus 5 halves plus 6 minus this fraction here gives us 72 minus this fraction here gives us 90, and then this one gives us negative 36. So that, if we work out these fractions, gives us 19 over 6 minus, and this bracket gives us negative 54. So now that means that our area under our curve is going to be 343 over 6 square units, or 57.16 recurring square units. So that's it. We're done. So to find the area between two curves, you first find the difference between the two, and then you find the roots of that difference, and that gives you your integral bounds, because the roots of your difference lines up with the crossing points of the curve. Integrate that function and you will get your answer in square units.